Welcome to Engineering Scale Models. I'm Jason, your host, and I do models and electronics and Nintendo Switches. That sounds pretty cool. So, I'm doing a live stream here, gonna work on some Nintendo Switches. I have one that the fuse blew and it threw me for a loop. It really did, and I'm going to take a look at this fuse and diagnose this a little bit more. Because what happened was that, let me switch the camera here. I have the face cam. Hi, hello. Hey Reese, how's it going? I shorted out the M92 chip on this board. This is the first switch that I worked on, and I shorted out M92. And I changed it. Let me just put up this camera. Oh, that'll work. So, there's my changed M92. And it didn't work. It drew 0 amps. And I changed it again, thinking I messed it up. And after the third time of changing it and knocking off all those capacitors and messing up this whole section up here and this whole section, I was like, okay, there's got to be something else wrong with it. And I went back and I checked this fuse right here, and that fuse is blown. So I checked it in the beginning, but apparently when I shorted out M92 on accident, not on purpose, I blew that fuse. So if I come in here and I go to continuity on the meter, meter, a lot of buttons to get the meter going. There we go. So if I come over here and I check for continuity on this, nothing whatsoever. So I immediately messaged the coder, and I was like, oh my god, can you believe this? And I found 2 amp food. Yeah, 0 ohm resistor. Yeah, that's what I'm getting to. We found I found these 402 fuses, 2 amp fuses on DigiKey for like 56 cents a piece. And I held off on ordering them, and last night the coder did a stream, and he found out that they're 5 ohm resistors. Yeah, so I was going to put, instead of buying the fuses, I was going to put a 0 ohm resistor there. But he said that they're 5 ohms, so I'm just going to confirm that on my working switch box I got here. Because if it's a 5 ohm resistor, that's even better, because they're supposed to be rated for 2 amps, and 2 amps at 0 ohms at 15 volts is 30 watts of power, and I don't think a little resistor like that is going to crank out 30 watts of power. So the meter's in continuity, but it'll give me an ohm reading. Well, it's really jumping there, isn't it? Now I don't know anymore. I'm going to check it with the LCR tweezers. So what I'll do is I will move the scope closer to me, and I will, let's see here, bear with me a minute, and I'm going to put this down there. Okay, so I have the same sample component book. Yeah, I have the sample books from 0201 up to 1206, so I'm set on that. So I'm just gonna slap in the whatever this is, but I don't know, that read a little bit low, so I'm gonna read it with the LCR tweezers. and see what that says. I don't think a 0 ohm link would really make a bit of difference. But let me see. Can you guys see the tweezers? That. Yeah, about 5 ohms, and it's dropping to 3 because that capacitor's charging. It's gonna keep dropping. What? Yeah, this capacitor here is charging and discharging, so it's giving me a false reading here. Now I'm reading in the megohms. So this is a little trick that I have for dealing with a situation like this. If I can set it up here, I am going to take this right here. Now, this is a little trick if you're reading a component in circuit and you have a capacitor that is charging and discharging on you with when you're taking a reading. This is what you can do, and I've done this trick for years. You can take a pair of tweezers. So this is a pair of just back this up a little bit before I do this. Hey Andy, how's it going? This is a pair of tweezers that plug into a multimeter, and what I did was I put a connection that puts these two together like so, and now when I touch these two, they're the same point. So if I come in here and I yeah, you're gonna be able to see this. If I come in here and I grab, this is gonna be tricky without blocking the view. I'm gonna have to turn it this way. So let me see, can you get in? So I'm gonna come in here and I am gonna bridge this capacitor because I believe that's the capacitor that's been shorting on me. So I'm gonna bridge that capacitor. I'm gonna turn back on my LCR tweezers, and I'm going to attempt to get a better reading. Okay. What did I get a? Okay. So it's not going to give me a good in-circuit reading on that fuse. But see, if I let go of that capacitor, it's going to slowly charge it and drop in resistance. So I'm truly not going to know the value of that resistor unless I... Yeah, see, I don't think that it's a... I don't think it's a 0 ohm link. I think it's a 2 amp fuse. Because I found them on DigiKey. But I'm gonna replace it with a... Why won't these turn off? I'm gonna replace it with a 0 amp. Yeah, short out the cap to get rid of the false reading, but I think because something else is doing it, because if you short out the cap, it's not going to charge and discharge, so it will basically bypass. Oh yeah, he ended up, the coder ended up streaming after, which is it, 5 or 6 tries. It finally worked, and he ended up fixing a Nintendo Switch that threw all of us for a loop. Yeah, that was, yeah, would have never called what that was. Well, what it ended up being. So, I mean, it actually says, it actually has either a 5 or a fuse symbol on it. Let's see if I can get in close enough to show you that. I can find it now. See, either that's a fuse symbol or a 5. I don't think I can go any closer than this. Yeah, that's about as far as it goes. See, it's either a 5 or an S symbol, like for a fuse. Shame I missed it, but that's your face. Yeah. Yeah, it was pretty good. I was really surprised. So I didn't get the reading I wanted on that, and shorting that capacitor didn't work. So I'm not sure. I feel more comfortable putting a 0 ohm link in there until I get the 2 amp fuses. Let me see if I can pull those up on DigiKey here. Let me see here. I don't normally do DigiKey out here. Okay, so it is a 0402 fuse. Okay, if we come to, what is it, monitor 2? Yeah, there we go. I knew I'd figure it out. My Stream Deck is not in the best of. Yeah, you think it's a 5.2? Yeah. It could be a 5 ohm, but I'm going to check it out. So if I come over here and I go to service mount and I go to 2 amp fuses, and we're guessing it's about 2 amps because that's what, that would give it plenty of protection. And if you come down here, it's this one right here. See, this is a 0402. I'm not sure the component size of the fuse that is on this. We're torn between 0402 and 0201. I can't find the size fuses in 0201, but if you buy 10, they're 56 and a little over 57, about 57 cents when you round up. So I got that, but if you go in here and you look for 0201 fuse, you don't get you go to fuses, you only get 9, and none of them are surface mount 0201 size fuses. Let's try SMD fuses. Okay, let's go to fuses. See if we can narrow this down. Let's go to 2 amp. Well, let's check 2, 1.8, 1.6, and 1.5. And then we want surface mount. And we want a size. Oh, it's not going to give me a size in the component. That's weird. Let's apply that. If we look down here, we have these are 1206s. 680s. Yeah, I'm not seeing anything. I don't even see where they label it as 0201. I mean, I saw the 1206 rating. Yeah, I'm not seeing it. So really all I found was those 402s. Is that what it is? 402? Yeah, 402. You would think they would have it by SMD component size as an option to search. Yeah, I'm not seeing any way where it tells me the size of the, like the component size. It must be, fuses must be not registered in the actual component size of 0402, 201, or things like that. But I was able to find the 0402, so I'm not sure here. This is just, yeah, this is going nowhere. So I did find those ones, so I might try them, just for an experiment. It's not that much. Yeah, I just put 2 amp fuses. Yeah, they never draw more than that. Yeah, that's what I'm thinking. But uh, Phil, the coder last night, said that he did a test, and he said they were 5 ohms when he was checking them. So I might put a 5 ohm in there. So let's go back out here. Sorry for the blurriness. I have to get back out here. So we are going to pop that fuse off of there, because this is the bad one. Make sure, yeah, this is the bad one. See, I label it so I know which one's the bad one, so I don't mess it up. 6th one down. Two amp. Let me go back to that. No, not that one. This one. You're talking about this one right here? That can't be it. That doesn't even say what size that is. Was it on a different page? Let's see if I can. Okay, so I can get it in 603 and 1206, but I don't want 603 or 1206. Let's get rid of the current amp rating, and let's see if I can get it in that now. Yeah. Scroll to the right. Yeah, see, it gives me the size right here. Where's it at? It gives me the size. Here's 0603, here's 1206, 1612, and 2410. But I'm not even seeing the 040, the 0402, 0401. Was it? Oh, I can't ever. I'm getting confused with my numbers. 0402. If we just take off mounting type, do we have 0402? We do not have it again. So let's take off fuses in general, and let's go with surface mount and size. See, there's the smallest they have is 0402. I don't see anything smaller. No, it was on page 1. Oh, I can do that. Let me just... Let me go back here. So let's go back to page 1. And there we're back on page 1. 1, 2, 3, 4, 5, 6. So, well, that's 63 volts. That's a 1206 fuse. That one's 1206. Yeah. Yeah, yeah, if I go up here to here and I get rid of all the search options and I just go with surface mount fuses, it gives me the smallest. Where's it at? The smallest size it gives me is these 402s. So if I apply that, like here's 500 milliamps. Here's another 2 amp right here, 32 volt. This is only 25 cents. I don't know, does that look more similar? It's a Panasonic. Oh, what do you guys think of that one? Yeah, it's alright. What do you guys think of this one here? It's an 0402. Yeah, it doesn't look far off. So I am going to put, how much are they for 10? 22 and a half, 22.8 cents. I will take 10 of those and add those to my cart. And I'm going to go back to my searches. Okay, let's see. Yeah, that one was pretty close. I'm gonna limit it to 2 amps. Actually, I'm gonna do 2 amps and 1.75, 1.6. Because I think a 1.75 would work. See, this one actually has something written on it. Oh, that one has F on it. That's not it. So here's a 1.75. Looks pretty close. Yeah, thank you. Thank you, Reese. There's a 1.6. Just hoping I'm going to see one that's going to have like a 5 or an S on it. Oh, that's 1,000 minimum quantity. Yeah, I don't want minimum quantity of 1,000. So this is a 24 volt one. See, it really doesn't need to be more than 20 volts. So here's a 24 volt one. That looks pretty close. I mean, that looks pretty close right there. It's an obsolete item, but I can buy 10 of them. I don't mind buying some of these. And we'll find out which one works best. Yeah, I think 32 volt may be a little bit more than outside of the spec, but that does look pretty close. Let's see here. There's 1.6 at 24 volts. You have a 1.75 at 24 volts. No, 1.75 at 32. Oh, okay. So, I think 1.6 would be too low. So, let's just look at the 1.7s. There's only two. Yeah, I'm gonna try those two. So, okay. Well, I'm still only at $10.68. Okay. Well, that I need $25 to do the order. I'm guessing the voltage rating isn't as important as long as it. Yeah, it'll the charger can put out 15 volts, no problem. If you plug it in, it'll the actual Nintendo charger will put out 15 volts to the charger and about 1.6 amps. That's why I think a 1.75 would work. That's just me. Where is that original fuse that I found? Let's get rid of this one here. And let me go just to 2 amp. Yeah, it doesn't need to be 32 volts. 24 volts would be fine. Okay, so here's the original one I found. And now that I look at it, they don't look close. They don't look right at all. That's 60 cents a piece. It's ridiculous. Oh, whatever. I'm going to buy 10 of them. Okay, so maybe I'll come up with some more stuff to get. Alright, let's go back to fixing this thing. Okay, so we're back on here. Yeah, if you take a, here, I can show you this right now. If you take a, I can show you on this one because this one works. If I take this board here and this battery, and let me get my meter here. I need. So I have a regular 5 volt. Let's make it so we can see this a little bit better. And that microscope light is drowning out my overhead cam. Let me just lighten that up a little bit. Okay, so if I take a regular USB C cable and I plug it into my protected USB-C unit up here. I don't think I can show you this. I don't think it's gonna. Okay, there we go. That's gonna work maybe. Yes, that's working. Okay, so then I take the USB-C port and I plug it into my USB-C meter. And the meter's actually going to turn on and show that it's drawing 24 milliamps, which is very, very frustrating. So if I zoom down here, I'll zoom down a little bit. And as you can see, it's saying 5 volts right there. And if I plug it into the switch, this is a good working switch. So this is my test bed system here. And if I plug this in here, it'll say 5 volts, and it'll start drawing and start charging that battery. So there you go. It's 4.9 volts. Bumps up a little bit, and it's drawing fast charge now, so it's charging that battery. But if I come over here and take the actual Nintendo Switch charger, and I plug this into here. And then I plug my battery back in, and I plug the charger in. It goes right to 15 volts. So the main switch charger can put out 15 volts. So there it goes right there. So yeah, it'll put out 15 volts, so it'll give you a little bit faster charge, put a little bit more power in the unit at one time. So unfortunately, I can't test this on the one that we're working on because it has a bad fuse that we're going to deal with. Oh. Hey, Zanzazarwini. Oh man, I probably butchered your name. I am so sorry. What are we on? The same switch as the last videos. Actually, we're working on the first one first. And then that third one, this is switch number 1, and it has a fuse that has blown, and we're going to replace it with a 5. We're going to start with a 5 ohm resistor and see if that works. So yeah, if you put your switch on a normal switch dock and charge it, because most people don't charge through their a USB cable, they're not really going to notice much here. All right, I'm going to go full screen in a second, guys. Hold on. What's everybody's opinion on the face cam? Do you guys like it? No? I mean, I could go either way on it. I don't care. Phil was telling me that the YouTube algorithms recognize a face and promote videos more, so I'm not sure if that's going to be a thing or not. Alright, let's grab 402 resistors and see if that's the right size. It could be. I'm looking for... I'm just going to put a wire link in it at the moment until I figure something out. Does that look like that component? That might be 0402. Alright. It's better than that 0201 stuff I was dealing with the other day. Come on out, buddy. Come on. This is insane. This won't come out. Normally that's all they want to do is come out. Okay, so now it's stuck to my tweezers. Okay, so that looks to be about the right size. And I just flicked it somewhere. Okay. Yeah, that's gone. So let me just make sure it didn't go anywhere on the board. Yeah, that was gone. That just went away. So I'm going to pull this wire link first, then I'll put another one down because that was probably what I should have done, but I wanted to check the size. So let's get some hot air on here. That's off. Let me change my hot air nozzle. I do not have the best hot air station, but I don't mind it. I think it's fine. I will be getting something the first of the year, but right now I am not getting anything. Let's go to full size and get rid of that one. Okay, so I am going to Turn my air on to about 35%, and it's at 450 because that seems to work for me. And just because a little bit of flux is the one that is charging and doesn't display anything. Did I check if it's version 1 in the RCM mode? I'm not sure what RCM mode is. I don't know the difference if it's a version 1 or 2. I know how to check on the serial number on the case, but this one didn't have a serial number on the case. I like to know if the switch turns on with a charged battery. This one, no, this one didn't turn on with a charged battery, and this battery, the battery that was originally in it was fully charged. So this is the one from the videos that have been coming out, and I did a video where I changed M92 for the third time because I thought that was my issue, and it turned out that when I shorted out M92, it blew the fuse. So apparently the fuse is important. So I'm just letting my air heat up here. Okay, so sucker's on there. Turn up my airflow a little bit. Yeah, I was just saying how this air gun normally doesn't give me any issues, and I don't know why it's not doing anything. It's not even really bubbling the solder. It's hot. It doesn't seem like it's 450. There it goes. Oh, maybe not. I don't understand why this is not getting hot enough to... Okay, maybe Phil was right. I need a new hot air station. Because it's melting the joints of that transistor next to the hot air gun, but not that fuse. It's... there goes the... yeah, it doesn't want to come off. Okay, so let's get the iron out here. I don't know. Yeah, version 1 is hackable and the RCM doesn't display anything. until you send a payload. Oh, okay. It doesn't have any obvious shorts right now. PS1, it's charging and not displaying anything. It's worth checking. Does the previous... Oh, okay. Yeah, I will check that out when I get it back to where it's charging and stuff. I wasn't aware of that. Okay, let's get some solder on here. Let me see if I can just knock this component off with a blob of solder. There we go. Got that out of there. Let me just add a little bit of flux and clean up those pads a little bit. This is going to irritate me if that hot air station is giving me issues. Alright. So, let's see here. Let me clean up the area. Alright, so this hot air station is new. If it doesn't shape up and put components on the way I need to, I am going to send it back and get a different station. I think I may do that anyways. Alright, there we go. We got the component. We can see it. Alright, so it's going to stick to my tweezers, of course. Not ping it off again. There we go. Alright, so I'm going to get a little bit of flux in the location. And I'm going to turn my airflow down. And hopefully I can put this component on here with no issues. I did some smaller components like this. Yeah, for some reason this is not seeming to heat this area up at all. Because that should be melted lead solder. There we go. Well, that seemed to have taken forever. Alright. Wow, that was insane for time. Alright, everybody saw that pop down in the place, so that should be good to go on this one. Alright. Now, I'm going to let that cool down. Let me clean the area here. Not too bad. Getting better at these little teeny tiny components because I keep knocking them off or I keep having to change them. Alright, so that is that on, so let's check it just for giggles on continuity. The meter's still on the screen. Yep, we're good. 0 ohms, 0.3 ohms, same difference. So, let's see what happens when we hook this to a charger. I will move this out of the way, get rid of that, and are we good? Is everybody ready for this? Because it's still a little warm. So I'm going to let it cool a little bit more. I'm going to put my resistors away. Can I call you Z? Because I'm going to butcher your name every time, and I feel awful for that. If it charges and doesn't show anything on the screen, I should do it's probably in recovery mode. Is that what you're saying? Because that would be fantastic if that was actually the case. Let me just double check on the case and see what is going on here. Oh, it does have a serial number on it. You can tell me anything about that number. There is the serial number for this one. I thought this one had it removed, but that is the serial number. Anybody wants to screenshot that and take a look at it. Leave it up there for a little bit longer. Okay. Sorry, I'm just drinking some coffee. It's still in the 6 a.m. here. Alright, so I don't know, we'll see. Alright. This should be cooled down enough. Yep, should be good. I am going to hook the battery up to it. I am going to get the charger out, the charging lead. And I plug it in. And immediately, oh, there it goes. 15 volts at 500 milliamps. Will it bump up to fast charge? Will it? Oh, you didn't see it. Oh, I feel bad now. Okay, so it's drawing 15 volts, 500 milliamps. It's probably most definitely charging that battery. Should bump up to fast charge. So it's not going to go into fast charge. Zag, okay. Yeah, Zag, thanks. I'm really bad with names. I'm really bad with names. I get names in my own family wrong. So, yeah, see, it's straight 500 milliamps. So, I know it's charging the battery, but it's not going into fast charge. So there's definitely something else wrong with it. And M92 has been changed 3 times, and I've gotten to this result. This is the second time I've been to this result to where I had an issue where it was drawing no power. I changed M92 and I got back to this position, and then I was doing some voltage readings and I shorted out M92, and then now I'm back to this section where it is technically charging a battery, but it won't go into fast charge, and it's doing it at a very slow charge. When this battery, you saw it on the working switch, it went to fast charge right away. It's what, version 1 unpatched. Unpatched means it's hackable. Oh, well then I kind of hope I want to get it working, because I think they're worth a little bit more money. Yeah, well, I definitely want to get it working now. So what do you think, it's in that recovery mode and that's why it's not working? Now I'm drinking iced tea. Oh, okay. Well, we're gonna. Oh, I'm so gonna put this back together. All right, we're gonna put this back together right now, because this is some good news I'm getting so far. So let's get this bad boy out, and well, the screen's messed up, so let's put this here. Okay, so we are gonna get this in here. We're gonna try to do it the coder's way. Not off camera. Oh my god, that is so much easier. Oops, that one goes there. To get this ribbon cable out of here. I don't see how he does this. There it goes. Well, I guess that does work. Alright. Take back some of the labels I made him. Oh, it's got the Wi-Fi cable under it. Of course it does. Wow, the Wi-Fi cable's way underneath it. Take it back out now. Okay, so let's get the Wi-Fi cable out of there, because that was annoying. Let's get this cable back. And this cable. Sorry, I'll be looking at chat in a second. Okay. There we go. Okay, I think I managed to salvage every cable from here while managing to have that LCD connector plugged in. I don't think I'll do it that way ever again because I was not a fan of that. Why is that so bouncy right there? I definitely got all the cables. Okay, so we're going to plug in. Oh, do I need touch to get it out of recovery? Hey, Phil, how's it going? Did you just witness me get that LCD in first and then struggle to get the rest of it in? That was horrible. Okay, Tegra is in the software to send a payload and hack the switch basic payload. Yeah, but if you need only a PC and some software to check it, then So I have no way of just turning it on. Well, we're just gonna turn it on and see what happens. See if anything happens. So I put a 0 ohm link in that where that fuse was, Phil. And I found some better matches for the fuses on DigiKey. We had that fun earlier. Okay, so there's backlight and LCD. I'm not going to hook anything else up. So if I take the charger, let's put a battery in it. Battery in it. So if I take this and I put a 0 ohm in there because when I did actual readings on it, shorting that capacitor near it, it was all over the place. So I just put a 0 ohm in there. So if I plug this in here like so, seriously, nothing gonna happen. Oh, it was, okay. Now it's not drawing anything. When I hook the LCD up. It's not drawing anything now with the LCD hooked up. That's strange. I'm gonna take this back out here. I think this LCD may be bad. So let's see here. All right. I'm going to take this. I'm going to hook this battery back up. And plug this in. Yeah, see, it blew M92 again. Either that or that fuse. No, because it's taking 15 volts now. Let me reset the meter here. Oh, see, now I reset it. Now it's drawing 500 milliamps. But when I had it hooked to that LCD, when I hey Jinxie, I mess up names. Okay, so not hooked up to the LCD, it draws this. hooked up to the LCD, it basically nothing. So, who wants to say I try another LCD? And this battery is ready to go in fast. This battery will take the fast charge, and this won't go to fast charge. Zag is saying if it's unpatched and was hacked, that if it's in some RCM mode, it won't go into fast charge, and it won't display on the screen. What do you think? Let me, I have a more accurate meter set up on my bench for power consumption. Let me see what exactly this is drawing. So this is drawing exactly nothing. What? This is drawing nothing at 5 volts from a 5 volt USB-C cable. Huh. Is my meter frozen? Let's check it now. I'm having technical difficulties. Okay. Yeah, see, that is weird. Why is that doing that? Yeah, see, it's drawing amperage now. Okay, this is odd. At 5 volts, it doesn't take any charge. But at 15 volts, it takes 500 milliamps. What? Phil, did you see this? Phil, please tell me you saw that. This is the weirdest thing. Could you not drop your multimeter across the battery terminals to check the reading? Yeah, I can put my multimeter across the battery terminals. Let me find my meter. You know, I have 3 screens and I still lose stuff. Let's go to DC voltage. Okay, so multimeter across the battery. Let's grab another set of probes here. And I'll pull this off of here. Alright. So check across the battery. I have 4.1 volts on the battery. If I check the coil, I have 4.2 volts on the coil, so the battery's getting charged. But why is it charging the battery at 15 volts, but it doesn't charge the battery at 5 volts? Why doesn't it do anything at 5 volts? What's the voltage on the battery at 5 volts? Yeah, see, it's not even passing 15 volts to 5 volts through. I'm getting battery voltage on the coil. Let's just double check that. Yeah, see, now I'm getting battery voltage on the coil. So it's not taking any kind of charge. No, I didn't see it. My son was... what voltage drop do you have on the amp meter when it's charging? Okay, listen. At 5 volts, it doesn't charge at all. This is not charging. This meter draws 24 milliamps, so it's drawing like 1 or 2 milliamps. But if I plug in the Nintendo charger that does 15 volts, it draws a half of amp, 500 milliamps. Yeah, when it's at 15 volts, the voltage drop on the... I'm not sure what do you mean by the... kind of voltage drop do you have an amp meter when it's drawing? Let's see, 4.94. About 60 millivolts. See, it's not going to jump up there, but if I unplug the charger and plug it back in, it's a half an amp. And yeah, about 60 millivolts is the drop from the base voltage. Hey RB, how's it going? Have you ever seen this before, where it doesn't charge at 5 volts, but it charges at 15 volts? This one's getting weirder and weirder. Yeah, the battery's at 3.8 volts. It's still good. It's actually charging the battery right now at the 15 volts, but it won't. Yeah, I'm doing good, RB. I'm just this is throwing me for a loop. I never thought to check to see if it charged at 5 volts. I just used the OEM Nintendo charger, and I've never had an issue, but it's weird. In RC mode, it also doesn't display this charging symbol. Yeah, it doesn't display anything, and it's weird. No, I never seen that. Is that the one you put the 150K? No, this is the first one. This is number 1. This is the one that was originally no power and BQ, and the USB port was changed, and I shorted M92 out on and just changed the fuse on. So, the one that I gotta change P13 on is the one with the different resistor. Yeah, this is the very first switch that I was sending you the pictures of that I kept changing M92 on when it was the fuse. Oh, there's my son. Yeah, of course you never seen that. You never seen that coil go bad either last night. Alright. Oh, this is odd. So, again, if I plug in 5 volts, nothing. That's weird. That is so weird. If there's a transistor between the battery charger and baby, maybe needs a higher voltage to open the gate. Yeah, but it should charge at 5 volts. Alright, okay, that's pretty weird. The 15 volt charger. Can you drop to 5 volts? It's an OEM Nintendo charger. If it can give 5 volts, it'll give 5 volts. If it can give 15, it'll give 15. I can't drop that 1 to 5 volts. It's the Nintendo charger. I might be able to make this one go to 15 volts. No, can I? Can I make this one? See, this is the problem with these meters, is they have all kinds of switches on them. I can never tell which one does the, I don't know, that's the on-off switch. Yeah, that's PD though. Yeah, I can't get it to take 15 from that. So, try increasing the 5 volt. Yeah, I don't, it's a USB plug that's plugged into the computer. Or not the computer, a very reliable USB hub. I don't think I can make it jump to 15. Let me try this. Let me try taking out that from the circuit. Let's try this here. No, it won't ask for 15 volts from the actual charger that can give 15 volts. What I can do is we can try this here. Let's plug this in. This may be fun. This could do all kinds of weird stuff, but we already have weird stuff happening. Let's turn this on, because this will give me something. Anything? Anything? Okay, that's not giving me anything at all. That is weird. Oh, that wasn't plugged in all the way. That's why. Let's try it now. Okay, so there's 12 volts, and it's giving me 5 amps. So it's taking 12 volts there, and it's giving me 5 amps, 0.5 amps again. So there, you can see that. So at 12 and 15, I get half an amp, but at the 5, I don't get that. I really can't vary this anymore. Well, let's... I guess we can have some fun with this. It's already not working, so... Let's do it. We're going to have some fun with this. Just bear with me for a minute to set something up. Alright, we're going to do it this way then. We're getting out the custom cables. This is that one. No, it's not that one. It's definitely not that one. As soon as I find the right cable, that's the one. So here we go. We have the right cable now. Okay, so let me put this on the screen right now. Power. So I'll try dropping the voltage to see how low it will go before it doesn't let you charge it. Yeah, that's what I'm about to set up right now. I'm getting it set up right now. I didn't have the power supply set up at the moment. Open that. Okay, well, that just... Yep, every time I connect that, it kills my meter for some reason. There it goes. Okay, so let's put power on the screen, and let's set it for channel 2. And let's set it for, let's try 5 volts, and we'll see what it does at 5 volts. 5 volts. and we'll give it 1.5 amps. Okay, 5 volts, 1.5 amps. We will come over here and we'll plug this in channel 2. Alright, so plug this into my makeshift. This is a very dodgy setup. Okay, that's definitely not the right size cable. What? Why is that not the right cable? Okay, this may become a lot more unstable. Okay, so this is definitely the right cable. Alright, really have this set up here that's weird. So we're going with weird. Okay, I have to make sure I set this up correctly. And I need to make sure that this cable is plugged into this meter. Now I can't display this meter on the screen yet, but it will give me the exact current draw. Okay, shift current. Okay, so this is the system. This is the power in. Okay, this is where it gets weird. So the power in comes into this side here, into this side. This side is the current sense of the meter, which plugs in here. It's weird. And then this is the output to the USB port. So this should plug in there like so. And alright, let's turn this on. Okay, so it's getting 4.6 volts and it's not drawing anything because the meter's drawing 25 milliamps. So there's 5 volts. Hey, I think I watched the video. What do you do if the switch discharges? Okay. All good. Okay, so at 5 volts it's not doing anything, so let's pop it to, let's go to 6 volts. 6 volts, anything. 6 volts, nothing. Nothing. And let's go to 7 volts. 7 volts, nothing. Yeah, y'all can see this. So, and 8 volts. 8 volts is absolutely nothing. So let's try 9 volts. 9 volts is nothing again. Let's try, we're just going to try 11, we'll try 10. 10 volts. And 10 volts is nothing again. And 11 volts. 11 volts is nothing. It should charge at 12 because we saw that on the other supply. Okay, so it's charging at 12. It's just not liking the charge from my power supply. Yeah, see, it doesn't like the setup. It doesn't like to take a charge from that because if I plug in the other charger, I told you it was a dodgy setup on the power supply. I think it needs to communicate with the data lines, because there it is at 15 volts and drawing a half an amp, but I couldn't get it to draw anything. I think I can give it 8 volts too from a different bank. Let's see what this says. This should give me something different. This is again 12 volts. Okay, let's try the USB cable. Let's try the USB cable in here. 5 volts from a power bank. Okay, there's 5 volts from a power bank and nothing. Again, nothing. So no, this one doesn't turn on. Nothing happens. And when I plugged in the screen, it stopped taking voltage at all. It stopped taking anything from the power cable at all. It just dropped down to no current draw when I plugged in the screen. So, alright, so let's put that back. Let me just neaten up just a bit here, and I'm going to change P13 on another switch. Just got cables going everywhere. No, P13 hasn't been changed. It's about to be changed right now. Yes, Donovan. Why are you in school? It's not school day.
Oh well, that's just
Okay, you can go ahead and watch your YouTube, buddy. My son came out to the workshop.
Hello.
Alright, why 5 volts only would be enough to run the circuit C?
I can imagine you watch YouTube. Everyone likes YouTube.
Okay, shh, Donovan.
Sorry.
That's alright, buddy. Okay, so we're going to put that back. Now we're going to change P13. That's what we're going to do. Because that was originally what the stream was supposed to be, but I changed that fuse first to see if I fixed my problem, and then I got into testing it, and then I saw the weird thing with the issue. Okay. Oh, Phil, yeah, you weren't here earlier when my hot air station couldn't change the fuse. So I'm sending it back and getting a new one. Yeah, we're plugged into the LCD. Yeah, I'm gonna change it right now. That's what we're doing. So yeah, this hot air station wouldn't pull that fuse. It wouldn't get hot enough to melt to pull the fuse. So I'm going to send it back because it's still within the return date on it. So I'm gonna have to change this nozzle again. Yeah, I'm gonna get yeah, I'm thinking about it. Yeah, I'm highly thinking about it. I have to see if that guy still has that quick for 100. New in the box. If not, I'll get in that. Because this is, yeah, this was a nightmare. It wouldn't even change the fuse. It wouldn't even change it. So, all right, we'll see how this is going to be. Oh, hold on. And we'll see how this goes. This is my first time changing this chip. Okay, so nothing got moved. I don't see anything moved. Oh, yeah, I knocked it off there. So that sucks. I'll fix it. I got used to fixing that stuff. So now it looks like I got some kind of like solder ball in between those two capacitors. What's up with that, right? How did that happen? Okay, so let's get a chip out. I think you should check the R's. Yeah, I'm gonna change this P13 chip, and if it still gives me the same issue, I'm gonna look into that RCM thing and pull out another switch and work on that. All right, so I actually have P13 chips. Check that out. That's exciting. They finally showed up. So, all right, let's move this one out of the way. Let's get this one out of the package. Alright, so... And you reckon I don't change the solder? Is that what you're saying? Yeah, I'm not worried about that cap. I'm not going to change the solder. I'm going to pull a fill. I'm going to pull a fill and just leave the solder on there. All right. All right. There we go. Alright, so that worked out better than I expected. Okay. If you leave the old solder, you notice the chip says... Yeah, that was old solder, buddy. I'm not doing that. I'm not going through that whole squirt out a glob and then, you know, knock off 4 201 components and have that kind of fun. I'm not doing that. Alright, I think I have a knife tip on my iron already. No, stop. Do that. I have a knife tip on there, right there. Let's get some flux on there. Let's get some fluxy. I'll get this on and then I'll fix that cap I took off here. It's not hot yet. Yeah. Rid of the bulb. Get rid of the bulbs and flow again. Alright. My son is apparently enjoying his YouTube video. He's laughing pretty hard. Okay. There we go. Alright. Donovan, you're being a little loud, buddy.
What?
You're being loud.
Sorry.
Alright. Here we go. So now reflow it again, is what he's saying. So more fun with this hot air station. Now it's crooked now. Go. Alright, it's been reflowed. Okay. Yeah, 201 caps, whatever. You know how I feel about those 201 caps. Alright, so I'm going to put a blob of solder on there. Wait for my gun to cool down so I can change the tip on it. Yeah, I'm getting that at I might not be able to make a video for about a week, but I'm going to send this back and then get the Atten. So no, anybody got like the face cam thing? You know, could you do without it? What's going on? Nobody's mentioned it, and I keep forgetting it's there, and I don't look into it. I'm not a fan of cameras. Oh, this is taking forever. Alright, we're going to put this cap back in place. Yeah, this is already getting on my nerves. Alright, so I'm gonna put, get a new station. Alright. Did we put the flux on that cap? Yeah, we did. Alright, so we're gonna come in here, and I can't even see that cap, it's so freaking small. Come on. Get on your spot. Come on, oh, don't do that. Don't do that. There we go. Alright. So, I got that down. So, yeah, okay. Well, I'm going to keep it all serious, though. If you can use a face camera, I know in mine. Yeah, I guess so. Yeah, whatever. 201 caps, man. I've done it so I've knocked so many off that I've done it so many times that it's like it's not a big deal, but it's just irritating at this point. All right, so P13's been changed. I'm gonna move that out of the way. All right, I swapped to the wrong thing. You know, I have a stream deck with pictures and words of everything it is, and I still managed to hit the wrong button. So that's always fun. Alright. Yeah, that's still pretty hot. So, hey, Andy, I agree. Yeah, if it's better for views in the algorithm, I don't mind it. I'm not a fan of showing my face. This is, other than that intro video I made yesterday, day before, this is the first time I'm using it. So, I figured I'd try it out on this live stream. So, still hot. No, it's better. I can clean it at least. Alright, let's... Well, you saw my flux there. It was pretty good flux. I mean, you saw how it worked. I like it. You know, I'm looking forward to trying that king bow, though. Alright, let's just double check to make sure everything didn't, nothing else got knocked out. Nope. Alright. Okay, well, this is cooled down, so let's say we hook this up one more time and see what happens. Let's plug in that. Plug in that. And we have 0.5 amps. And this should go into fast charge if it'll be able to go into fast charge. So I may look at that. I don't do. Yeah, that's the issue. That's funny, RV. So I still have the same issue. It's drawing a half an amp with P13 changed. But it's definitely at least charging the battery, so if I just keep it to charge batteries, but I don't know what the deal is with it when it's hooked to the LCD. Yeah, this one is weird. This wasn't even the one I was going to work on today. So, yeah, I have, can you check? You can check Vince's face with the reflections. That's funny. Yeah, that is true. He does do the reflections on the screen. Okay, so now there's nothing else left on here I can change unless I start checking BGA chips. So I am going to put this one aside and I'm going to check on Zag's RCM thing. I'm going to look that up and try to figure that out. Hey, Zag, my email is in the description of this video. Could you give me an email to like a link or something like that to where I can get some information on how to deal with this, with the hooking it to a computer and stuff? Because I'm going to, before I do any damage to this board, I want to check that one last thing and see if that works. But I think this is going to be a BGA practice board. Because, what do you think, Phil? adjust it. I'm gonna get this. Again, I am off camera. Alright. Okay. Let's try this here. Right there. Yeah, see, this just... There we go. I got it in there that time. Okay, so make sure I get all the cables out. In there. There's a backlight cable here. Okay, so I'm actually going to put a screw in it so I don't have to hold it. Just going to put a screw in it right there. I don't want to sit there and hold it. Okay, so let me plug in the backlight. Plug in the backlight. 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 Alright, so power button just for giggles. Power button is in there. Okay, let's put the battery in. Wow, I really gotta move that camera. Alright, battery's in. Let's get the charger here. Let's plug it in. And we are drawing 1/2 amp. No charge symbol. The battery is good. Do we get anything on the screen? I will be 10 wow, 10 viewers. That's insane. Oh, hold on. Someone said something about labels. I gotta check this out. Okay, yeah. This is the only guy who loves his labels. Yeah, okay. Do I use a dynamo? Yes, I do use a dynamo. 10 viewers, welcome everybody. Yes, 10 viewers, that's crazy. That's 3 more than last time, so that's good. I will be here to check what happens after you hook up the LCD. It looks still the same. Yeah, I hooked up the LCD. The LCD is hooked up, and I get nothing. No backlight, no power. It's still drawing 1/2 amp. Uh-oh, is it buffering? Come on, YouTube. No, not. What? That's what I want. Oh, yeah, it says my stream current bitrate is lower than the recommended value. What? It says I dropped 906 frames, 0.2%. Huh, that's weird. Yeah, you know what? I did mine early in the morning in the US, so I figured nobody would be on in my area. But I guess people are waking up and starting the game online, and it's it's starting to get issuey. Well, it's been an hour and 45 minutes. So this is where I'm at here. So I am going to check into this RCM thing. Told you, Jason, we will grow your channel. I'm sending you a thumbnail. Oh man, I appreciate that, Phil. I really do. That's awesome. So I am going to look into this thing Zag is talking about for the RCM for sure. I'm going to look into that, so I'm going to put this in its well-labeled box. Well-labeled box is the way I like it. That way, you see, everybody see all my screws are labeled too. Ooh, labels. This is like label ASMR. Let me tell you. Okay. So, let us see how much longer I have in me. Alright, now, that had turned, hey Jamie, how's it going? That had turned into, hey, I'm going to change a fuse, to, hey, I'm changing P13. That's where that whole stream went. I was just gonna change that fuse with that 0 ohm link just to see if it would work. I was hoping it wouldn't and I could prove Phil wrong, but it worked, so he gets bonus points for making it work. So I'm going to, this is what I was originally going to work on. This is the one from the last stream that I need my test battery back. I need my test battery back. I don't want to leave that plugged in anyways. Okay, so this is the one that I changed. Oh man, it was so long ago. I changed M92 and the USB port. So this one had both the USB port and M92 changed on it, and I will show you what it does when it has power to it. I believe it works on this side. It gives me, it bumps up to 499, and then it immediately shuts off and then reboots to drawing no current. But if I unhook this and then I hook it back up, I can make it do that boot loop thing again. See, there it goes. It's going to draw the current and then it's going to shut off. Now, there it goes. So that was what this one does. Yeah, it's 0402. I'm still ordering the fuses. I found some better matches earlier on the stream. You weren't here for that. Let me show you, so you might want to get them. I'm going to go to this monitor here. Right here are the ones I found. This one right here is 0.75. I just thought to look at it. But these right here are 22 cents. And they're 32 volts. And they look pretty close. So, and at, 22 cents, 23 cents for 10, that's cheaper than what I originally was getting was these right here. I found these, but these don't look like a match like the other ones do right here. Then I also gonna look at the 1.75 amp one just to look at it, and then here's a 24 volt, because it doesn't really matter. The voltage doesn't need to be 32, but 24 would work. These are a little bit more expensive, but I want to test them. I want to try different ones. But that's the I was in the land of Zeds. Okay, I don't get that. Yeah, so there's the fuses I found on DigiKey. So let's go back to. I need some more coffee. All right, Andy, thank you. So, we're going with changing P13 on this one also. That's what we're doing. So, we're going to get set back up here. We're going go there. And we're going to rip P13 off of here. And we're going to build up our little collection of chips that possibly aren't bad but could be bad. And then I'm going to figure out a way to test them all. Okay. So, I got to change that nozzle again. Oh, so getting a new air station. All right. All right. Let's put a little bit of flexy on there. I should have stuck with the other tip. So all right, that one over there. Get off my tweezers. Okay, so did we do better that time? Oh, we did much better. Okay, much better. Let's get some flux on there. Some flux. All right, let me get another chip out. Use a hammer. Yeah, that's what that hot air station is. It's a hammer. That's how it works. Yeah, you know, up until today, I never had any issues with that hot air station. It seemed to be fine, but I've only had it for less than a month, and it's already giving me issues. I'm not keeping it. I am going to send it back. Alright. There's pin 1 right there. Let's see if I get this one done any better. There we go. Alright, so let me turn my airflow down to about 30. Okay, so alright, I didn't get any blobs out that time. Alright. What I want to know is why are those test points? Oh yeah, we're pretty sure someone messed with this because they changed. Remember, they changed the USB port, and the pins weren't even tacked down. So I'm pretty sure that they were messing around. But I don't think that chip was changed before. Oh, it does make sense. I don't know. That's true. I'm not sure if that was lead-free or leaded solder. Man, that made the board hot. So, we're gonna let this cool down here. Oh, I got stuff on me. Alright. So we're gonna let that cool down for a bit. We will move this out of the way. And we're back to this. Yeah, there were some weird things with test points on this that were tinned. Like if you look right here, all these are tinned. Oh, and it took the camera off. Wow. Look, every one of these test points is tinned. You look over here, all these are tinned. So I don't think that is yeah, every test point is tinned on this board. So yeah, every single one of them. Yeah, every single test point has solder on it. So I'm not 100% sure on why that is. So yeah, it's strange, and there's like if you look right here, you see all that thermal paste? Like there was thermal paste everywhere. I don't know if they were using it for flux or what, but there was thermal paste everywhere. There was even thermal paste on the battery connector down here. It was nasty. Yeah, someone used it. Yeah, I don't get it. But from what I could tell when I did the first inspection, the only thing I saw that was changed on it was the USB port, and I replaced that, and it seems to be good. So I'm gonna clean this up now. See, that time I did it without knocking 201s off. I'm getting better at things. Yeah, I don't mind the whole component knocking thing anymore because it gives me practice to get better at it. Yeah. I have to hit that with the brush. Alright. Alright, get this cleaned up here. That was just alcohol. Oh yeah, dude. I don't think we're gonna hope BQ's not bad. BQ's not gonna get changed after 2 hours into a stream, so I don't have that kind of anguish left in me. You know, my knee starts to go after an hour, and I'm pushing through here. So let's see what we get now. Boom. Did we get the whole thing stopping? So we're charging up to 5, a little under, and it rebooted. And then it jumps up to 800 milliamps, and it's staying there. Huh. Phil. You're up, Phil. Tell me what's going on. Look at the meter and tell me what's going on. No, I don't know. It's probably working, right? It's not fast charging, though. Or is that fast charge at 15 volts? I got volts on the DMM. There we go. Let's check this battery here. Battery voltage is 4.1 volts, so the battery's being charged. I'm not quite sure why it's Dude, you seriously, it's getting warm. Do you want me to break out the thermal imaging camera? Oh, God, thermal imaging camera, seriously. Alright, we're going to break out the thermal imaging camera, and I don't believe mine is as slow as yours, but we're going to find out. So, I want to find out if they have the same level of frame rate loss. Alright, hold on here, let me get this going. Flare 1. Alright. Okay, there we go. There we go, okay. No, I don't want that stupid app. Stop trying to sell me that stupid app. Okay, we can get rid of the scope. That's just taking up room. Okay. So... I'm going to have to move this guy, sorry. Okay, so there is the board. There is what the board looks like. Let's put on the spot camera. Where's the spot thing? Touch the spot thing. There it is. Okay. So if we look here, and I can barely see that on that screen. It's saying that BQ is roughly, is that really saying like 131? No, that can't be right. 30, it's 30. Okay, my bad. Okay, it looked off to me. Okay, so we have it hooked up here, and I'm going to bump the heck out of it because that's what I do. So this side of the board is, you can see the battery protection board getting warm. This whole side of the board is warming up, but not like insane. What do we got? Where is the little dot thing? Okay, this area is, it looks like 50, and up here by M92. Is that M92? No, that's not even M92. It's like 57. What is that? Hold on a minute. I want to see what that is. It's getting hot right there. Is it right here? Yeah, it is. Let me show you under the scope what's getting hot. Okay, if I look at the scope right here, these three components right here are getting hot. These three appear they're probably MOSFETs. Those three components are getting hot, and then the same area and then the BQ area is getting warm, but the whole area is even the coil. Yeah, definitely short somewhere. Yeah, I'm thinking it might be, but yeah, these MOSFETs are getting hot. What are they? 62. I'm gonna touch it just to see. Yeah, they're definitely hot. Okay, yeah. So let's put this away because I don't want to make Phil feel bad because mine was faster. Okay. Yeah, BQ's warm, but these three MOSFETs are hot. They're way warmer than BQ was. I have to get my Pro out because it does a little bit better job. But it's these three MOSFETs. It's these three MOSFETs right here. Right here. 1, 2, 3. These were like hot to the touch. Like really, they're still warm. If we look under the scope here, that's the three MOSFETs right there. So I'm assuming they're MOSFETs. Oh, last night, this was FL1 I was telling you about right here. Not the fuse. The fuse is right here. This is the fuse. This was the filter I was asking you to check last night. This filter, FL1. This is a filter that's like the filter on the back of the board for P13. These are data lines for filtering out signals to power the switch on and off. So, I don't know how they go bad. Oh, you always test this filter? Yeah, I've seen you test this fuse, but I didn't see you test this filter. Okay, well that's good. Okay, I didn't see you, my bad. Alright, so we have these three MOSFETs, so let's do some readings here. I do not have the MOSFET readings on my cheat sheet yet. So, let me put this on big, and we still have the meter. So let me put the meter in diode mode here and get some readings and see what I can figure out. Diode mode. Alright, there we go. Alright, so I'm going to take this, clip it onto my port. And I'm going to take this and clip it on to my probe, get rid of the small. Okay, so let's, this is going to be the gate right here. And that should give me a reading of open circuit, theoretically. Oh, it's 0.69. Okay, so that's 0.48. Don't mind the beep, it's got a 2-volt threshold, so I can keep it even. Let's check this side here. This side, I almost forgot which one I'm working on. So, oh, wait a minute. That's weird. That is strange. Okay, I want to come in here and find that one again. And I want to test the junction from here to here. Dead short. Okay, dead short that way. That's okay. If that's a MOSFET, that's not normal. Yeah, dead short. So they're on the same line. So the power must come in here. So I want a diode mode reading from this output or input, whatever it is. Okay, so why did that go to open? So this should be source to drain or drain the source, whatever. And I'm getting a 5, so if I flip it around, I should get technically a different reading. Okay, I moved it. Okay, so yeah, that's giving me open, right? Yeah. Okay, so that is how you check a MOSFET. It should be open in one direction and give you a diode drop across the other direction. And I found that this is either the source or the drain, and then either one of these is the source or the drain. Not sure what power rail that is. Could be power in, but it's going through these. It's working through 3 different MOSFETs here. So on this one, this one may be 2 individual MOSFETs. So if I come to this side of the board, here to here, I get I get almost a dead short. That should be, so gate to ground here. Let me swap these. Alright, so, oh, you can't see. Okay, so, okay, so they literally must be hooked up to the same side. So let's check from these 2 points. Yeah, see, without knowing what the pinout of these MOSFETs are, it's really hard to tell what is the gate, what is the drain, and what is the source. Okay, so that is almost a dead short that way. And that's open line. So if I get a diode reading on this way, let's see. Oh, I should be getting a reading this way. No. Okay. So if these 2 are connected, are they also connected with this one? So these 3 pins, 1, 2, and 3, are all connected. And then it appears we have 2 pins, and then we have this pin that is connected there that goes to that MOSFET. But if that is the output right here, or is this the input and it outputs to 3 different rails? But I should get a reading if it's the output. Let's check these 2 here. Open. Open. Yeah, that's normal. So this shouldn't be open. This should be one way. That should be a diode reading. There should be a diode drop one way across this. So one way across this, there should be a diode drop. So I'm checking it the other way just to make sure I did it right. Oh, now I'm getting a diode drop. Okay. Never mind, that was good. Wow, it didn't diode drop the first time. Okie dokie. So let's check this last one here. Alright, I love troubleshooting. Okay, so this one is gonna be... Okay, so if we look here, it looks like, if you look at the tracks, it looks like this pin, this pin, this pin, and this pin are all either input or output, and this pin here is probably your output to this one. So I'm going to say these are inputs and outputs to this one, or inputs. It's hard to say, but I should have a diode drop reading one way across one of these pins right here. And that's giving me open. Okay, that's giving me open. This should be the same. Yep, that's the same. So let's check. Okay, that's giving me open. Let's swap the probes and see if I get a diode drop reading on the other way. So this one, not on that capacitor. And yep, I got a diode drop. So I don't think those. Oh man, I haven't been reading chat. I'm sorry guys, I got in the troubleshooting mode. That's what I do. Oh wow. It's yeah. Is BQ right there? It's short somewhere. Yeah, they shouldn't be getting hot. Yeah, it was just. That's the data line, yeah, USB detection. Yeah, that is the data line. I'm not 100% sure on data USB detection yet, but it is an important data line that if those filters are bad, you have an issue. Okay, so all are those are short. That would indicate an issue elsewhere. No, they're not short. They're just on the same track. Yeah, and well, these are a little bit different. Some of these have 4 sources in one drain. Um, no, I didn't really. The readings I didn't need. I just wanted to know if any of these MOSFETs were short across their drain and source, and that's what I tested for. If you look at, take this one for example, these are all on the same track, and then this one is the large exit track, and this is the small track, so this is going to be your gate, and whether one of these is the source and one of these is the drain, that really is irrelevant to me. I should get a diode drop one way, but not the other way, so they're not shorted. If I got a reading both directions, I would know one of the MOSFETs was shorted. I can hook mine up to a thermal cam. Hey, yeah, hook yours up to a thermal cam and see if that spot gets hot. But they were literally hot to the touch, not just hot on the thermal cam. And when I did a good working board, I don't remember those getting hot. And it wasn't M92. M92 wasn't getting hot. So let me put back in diode mode here, or set up for a diode reading. I want to check a few things by these MOSFETs here. 0.6. Disregard the beep, guys, because I'm going to turn it off because I'm injecting 2 volts here to read these diode readings. If I dropped it, then I wouldn't get. It's an accuracy thing. It's hard to explain. A normal meter only does, like, depending on what the meter uses to test the diode and what it gets back. This does a solid 2 volt threshold. So, yeah, do you even have one you haven't ripped the CPU off of? Okay, so if you look at the diode reading on this cap, it's not short. So let's check this one here. 6.2. This is probably ground over here. That's strange. Why am I not getting a reading on this side of this cap? Huh. Why is that open? Oh, that. No, I should be reading that. Okay, so there's a reading there. So I don't think this cap is bad. I checked the fuse, but check it again. Yeah, fuse is fine. Let me just check the filters. Should get the same reading on both sides of those. What? Yeah, that's better. Okay. So that worked out better. Okay, I thought that one was reading off. Now, I wonder what is on the other side. Oh, snap. Look what's on the other side of where that heat was coming from. P13. Oh my god, did I change P13 on this? I did change P13. I'm going to check for a shorted cap over here just to... No, cap's not short. Yeah, P13 is on the other side of the board, where it was getting hot, where those MOSFETs were. So I am going to quickly bring back the thermal imaging camera and look at the other side of the board. Because I didn't think of that before. Okay, let's see, here we go. Alright, let's get rid of that. Okay, so we're going to hook it up to the other side of the board and see if it gets hot. See what, seriously, what? I plugged in this is what it does. Okay, so let's go to this side of the board. Let's plug this in. Okay, I get no current draw on this side of the board at all. I don't think that port is sitting right. I'm not getting anything on that side of the... But when I do it to this side, I get... So, let's look at it this way. So... Yeah, it just looks like it's getting hot around BQ on the other side of the board. So getting more, which is normal. Yeah, MOSFET's about 24. Let's flip back over. Did you see it only works on one side of the port? So I think I'm gonna have to change that port. Let's see, where is the dot? Yeah, BQ is getting hot, but let's see here. See, this area is about 41. So they are definitely getting hot. Not as hot as BQ is. So but I think I'm already going to have to change the port because I'm only getting charge on one side of the port at this point. Yeah. Yeah, they're hot. They may even be a little bit warmer than BQ. Yeah, they're hotter than BQ. Yeah, they're 52 now. If I get this, yeah, 55, 56. So, I am gonna think about what I need to do here. If I don't have any way of changing those MOSFETs, so. Yeah, start pulling those MOSFETs. That's what I'm going to do. Well, that's not going to be this stream. It's been 2.5 hours. I was meaning to start with this board, but this will definitely be the next stream, and I will finish up number 1 in video format after I look into that RCM thing and see what things. Thanks, Zag. Yeah, long through the email. Yeah, that's cool. I'm gonna get on it. And I'm gonna do it in video. I'm gonna do it in video format on that one, and we'll see what's going on. This one's going to have to wait till the next stream. I might stream tomorrow or one day during the week. Sometimes it's hard during the week for me, but it'll be the same time in the morning, or the morning here, afternoon there for you guys. Thank you guys for watching. I hope everything works well for you guys, and I appreciate all your help.